Good afternoon, everyone. Today we're going to start our discussion on a very important topic in finance, and it's panel data regression. So let's first distinguish between the different types of data. Okay, so we have learned before one type of data which is called the cross-sectional data, and then we have time series data. And then you have panel data, panel data. So what's the difference between these three? Let's first take a look at it in terms of the number of units, the units being considered. Okay, the units can be firms, countries, individuals. Okay, so for a cross-sectional data, you're looking at many units. Okay, so for example, you're doing a regression analysis on different countries. Okay, so ASEAN countries. So there are, say, the whole ASEAN. So there are many units. You're considering many units. Okay. However, the number of periods that you're looking at is, period refers to the time frame, only one period. So for example, you're studying the GDP, GNP, inflation rate of companies that belong to ASEAN, many units, but only in 2024. So you have only 1 year time frame. That is an example of a cross-sectional data. On the other hand, if it's a time series, okay, you're only taking a look at one unit. However, you have many periods. Example, you're studying the pension system of the Philippines from 1970 to 2024. Okay, so now the number of units that you're referring to or you're looking at is only the Philippines. However, in terms of the number of periods, you have many. That's from 1950 to 2024. So that's an example of a time series data. The third one is a combination of your cross-sectional and time series. So you're taking a look at several units, okay, ASEAN, okay, and then periods is several also. You're taking a look at the ASEAN group, for example, Thailand, Malaysia, Indonesia, Philippines. So you have many units, and then taken across several periods of time from 1970 to 2024. Okay, so that's an example of a panel data. So of the three, the most robust, of course, is panel data. Okay, because it affords us the convenience and the insights coming from both cross-sectional and time series data. Okay, so we have done cross-sectional data. The wage data is a cross-sectional data. Now, today we're going to start discussing panel data, where you have many units and many periods of time. Okay, so let me close this first. Okay, now may I request you to please load the packages. Control C. I'm going to share this in the chat box, please. Of course, if you receive a message that a particular package is not found, then you have to install that. I'll give you a few seconds to install these packages. We could have, of course, used Pacman, which simplifies the process. If you're done, kindly please chat yes. Thank you, Missy. Wait for your classmates. Thank you, Cherry.
Wait, sir. Installing pa yung mga missing packages.
Sige lang, sige lang. Hmm. Okay, I hope the others are following along. Okay, a few more seconds. These packages we have loaded before and installed before, except for maybe PLM, GG, Grammar of Graphics Publication, and then maybe Far Away also, and F Basics. But the rest we have Gplots. Okay, good. Okay, so now that we have loaded these packages, let's first take a look at our data. We're going to use this price data. If I click this one class, okay, view file, let's view the file. Notice that, okay, it's a delimited, the values are separated by commas, or so it might be a CSV, comma separated value. Okay, all right. So what's the fastest way to install or import a data set? Okay, let's create a data called price, alt minus, and then what's the function class that we have learned in class? To load a CSV file. Anyone, please? Okay. What's that, Christian? What's your question? Thank you, Bea. But my question dito si Christian, ano yung question mo? What's masked?
Like ganyan po, sir.
Di ba we discussed already mask, di ba? Sabi natin na pag may mask, ibig sabihin, may dalawang package, there are two packages there that conflict as far as the, ano. But we ignore that, no? Di naman,
Okay.
di ba, diniscuss natin to dati pag sinabing mask, di ba? Okay? Alright,
Okay.
so may answer dito na ano yung class? Ano yung read underscore CSV? Okay? So why don't we try that class? Read underscore CSV. And then I hope you have loaded the data set. So you have price.csv. Any other thing that we should write here, class? Meron pa bang qualifier to, class? Ano pa? Class? Do we need to put more here? I'll delete all the objects here first. Is this enough, class? If you run this, what happens? What happens, class? Okay, column names is equal to true. Okay, so we have to include this column names. All right. So if you run this class, include column names is equal to true. Okay, so we have this. However, you have 80 rows and one column. If you view this, view natin, view, we have loaded the price data set. It's already here. View price. Are you getting this class? You have 80
Yes,
observations and you have only one column. Who among you got this? Feedback, please, class. Same result. How about the others? Same result, same result. Okay, so what's wrong with this? Is this data okay?
yes po. Na gumana po.
Ah, yes, pero lahat ng mga variables nasa isang ano, year, firm year, current ratio, debt to equity ratio. Should it be only one column? Should the, if you take a look at the structure of your price, sorry, not structure. Okay. Yan, tingnan nyo sa class. 80 by 1. 80 rows by 1. So what's wrong with this one, class? Anyone, please? What's wrong with that data? What's wrong with the data that we loaded, uploaded to R? Class, what's wrong with this? Okay. Okay, share your answer, Bea, to the class. And Carl, thank you. The columns are separated. You're correct, no? Kasi these are individual variables. Year, current ratio, debt to equity ratio, EPS, return on assets, total asset turnover, ROE, etc. So why is it that you're only having one column and it's including all your variables? Okay, so this is wrong, no? So how do we do that? Why is it that it did not split? It's primarily because this is not a comma separated value. So how do we load this properly? We can make use of the import data set. Click here. And then it's a text. Okay. And let's use read R. So let's click this. And then you can see here that you have to identify the data. You can browse and link it to the one in the files section. Okay, I'm going to link it to price here. Price, okay, open. Okay. Let me open. And you can see here the class that character to, no? It's a character variable. But that's not what we want. So yung code niya read underscore CSV. So it was assuming that this is a comma separated value. However, here class, we can change this. What if it's, maybe it's separated by a semicolon here. So you notice here that it's read underscore delim. It's not anymore read underscore CSV. It's read underscore delim, the data, and then delim is equal to semicolon. However, it's still wrong. Now let's choose another one, tab. TSV, tab separated values. Okay. What do you notice now about the tab? What do you notice, class? Is it now okay? All right. So we're now okay. So you notice that the code there this is coming from readr package. We know that. Read underscore delim. So it's not read underscore CSV, but delim, but you have to identify the delimiter. Okay. Delimiter is equal to quotes /d. This is tab separated values. Okay, and then there are additional default functions there. Okay, so I'm going to copy this class, copy, Control C, and then I'll import it, import. And then you can see that that code is here. And then I'm going to move it to my and paste it here. Okay, Control V. Okay, so when we view the price, you now see that the data is okay. All right, are you able to follow, class? Price. So have you
For what?
created this value price class?
Yes.
Okay, thank you. All right, now let's create another object. Thank you. Let's create another object and replace the price with panel data because I use panel data in the other sections here. So let's just create this object panel data, which is just the same as price. So you'll have now two objects here, panel data and price, but they're the same thing. Okay, so let me run this. So I now have this panel data, also 80 observations. I have 12 variables this time. Okay. And then if we get the structure of panel data, Control Enter. Panel data is a special table, 80 by 12. Okay, it's a table data frame, table or data.frame. And you can see that all the variables are categorized as classified as numeric. Okay, once again, let's pause and ask you if you are able to follow. Am I going too fast? Or is
A
my
little
pace?
po, sir. Can you scroll up pa sandali?
Okay.
Ah, /t. Okay.
Okay, it came
Wait
from
lang, sir.
here. You could have copied it, class, dun sa ano.
Maliping na type ko, sir. Sorry,
Mhm.
sir.
Pero dito
Salamat.
sa import dataset, pag nag-import tayo ng dataset class, lalabas yung code na yun dito. Here, that's why it's also here. Ito, no? It will appear in the console. Yan, delim. Okay. All right. So I hope we're okay. Okay. Now, notice, class. So let's analyze our data a bit. This is our panel data. Okay. Notice that what's distinct about our panel data is that it has a firm This is your individual units, and this is your period. Okay, so we have 80 observations. Now question, how many companies do we have? How many firms are there in this data? How many? How many companies are there in our data? Anyone? Okay. How many companies? Okay. Marga and Lisa. Yeah, you're correct. Thank you. It's 16. How did we know that, class? You take a look at firm. Okay. So firm 2015, you have 1, 2, 3, 4 up to 16. And then it jumped to 2016, right? 2016. And then you're starting with 1 again. 1 up to 16 here. And then 2017, you start with 1 again. Okay, you can see here. 2017. There, 1 again. So difficult to scroll down. Okay. So, and then 2018, it will start with 1 again. So you're correct. There are 16 firms here. How many years do we have? How many years, class? Class, how many years do we have? Years, yeah, you're correct. 5 years, class. So 5 years. 15 firms, 5 years. So it's an, you have, okay, you have M units and T years. If you multiply M by T, you have 80 observations. That's why your N is equal to 80. 80 observations, 16 firms, and 5 years. Okay. Now, we said that this is an example of a panel data. A panel data considers several or many individuals, many units. Here we have 16 units, 16 individuals, and many periods. Here you have five periods. So that's why when you multiply this, it's 80, you have 80 observations. And there are 2 types of panel data. You have your balanced panel data and unbalanced. So what's the difference? You have balanced panel data if all your units are present in all the years. Okay, so here we have 1 to 16, 1 to 16, 1 to 16 for 5 years, indicating that this is a balanced panel data. If it was unbalanced, then perhaps in 2015, you'll have companies 1, 2, 3. Okay, first 3 companies for 2015. And then for 2016, you might have 1, and then 3, and then 4, 5, 6, for example. So in 2016, no more company 2, but you have additional 4, 5, 6. Okay, so that's an unbalanced panel data. Some data may join later on, and some data may be deleted or removed. In our case, you have what we call a balanced balanced panel data, where all your 16 units, 16 firms are all present from 2015 up to 2020. And also your years, class, 2015, 2016, 17, 18, 19. Okay, you have 5. Okay, so there is no All right, so you have 16 all in all here for 2017, 16 for 2018. So all of them are complete. You have one observation per firm, okay, okay, per year. Okay, so this is 11, 2016. We'll have 11, 2017, etc. Okay, so this is balanced panel data. Okay, again, let me pause for a while and ask you if it's clear, if the balanced and unbalanced panel data is clear. Lucas? Okay, thank you. All right, I hope everybody's getting it. Okay, now let's go now to our regression. To do panel data class, we do not work on the regular data. This one. This is our regular data price, right? These are regular data. In fact, we created another data, right? Panel data. If we get the structure, let's see here, the structure of panel data. Okay, we know that this is a special table. Okay, it's a table data, it's a data frame. And you can see that firm has 80 observations, year has 80, etc. Okay. All right, so all in all, 16 times 5, that's 80. Now, the question is, class, when you work with panel data, you have to convert your data into what we call a panel data itself. So how does a panel data look like? We use the function pdata.frame. Okay, so this is to convert your panel data, and we're creating this object pdata, and our object is panel data, and then we have to identify the index. So what's the index? You have, first is the unit, next is the period. So our unit here is firm, right? This one. Our unit is firm, and then our period is year. So we have to identify it. Index is equal to firm and year. And then we we have it, we get the structure of the data. Run. Okay. Take note now that your classes is pdata.frame. This is panel data.frame. Okay. And technically, it's also a data frame. All panel data frames are data frames, but not all data frames are panel data. And see what happened, class. The firm became a factor. A while ago, it was numeric. Year also became a factor. The rest are the same. Current ratio is still numeric here. Debt equity ratio still numeric. So all the variables are all still numeric. Okay. Now, if we run this class, okay, p data. So let's print this here, p data. Let's view it here. P data. This is the data that we created by converting our panel data into a p data. Okay, what happens, class? What happened to our panel data, which we converted into a p data? Is there any difference? Did the content change? Is there a change in the content, class? Anyone, please? Do we still have the same data as the panel data?
No po, mas less po siya.
Much less in what way?
There's less shown po. It's more consolidated. Like,
Consolidated. Christian, ilang observations natin dito sa P data?
sir?
How many observations do we have?
There were 80 in panel data. Now
Now,
there's, I think,
how many? Okay? Sabi ni Marga, same content daw. Okay, if you scroll down, Christian, you still have 80. Okay,
Ah,
80 pa rin. Still, you take a look at this one, it's 80 entries. So the content did not change. Okay, however, there was a change in the arrangement. Okay, sabi, thank you, Marga, but please share your answer to everyone, please. Okay. Also, Ashley, please share your answers to everyone, please, so that others will benefit also. Marga said, same content, sabi ni Ashley, organized per company. Yeah, take a look at this. You have firm 1, 2, 3, 4, 5. Okay. This is firm 1 and it's 5-year data. Firm 2 and it's 5-year data, etc. until firm 16 and it's 5-year data. So everything is the same. It was just rearranged. And also notice one other very important difference. Okay, take a look at your printout class. Is there something here showing in my screen also that's different from this one, the panel data? This is your panel data. This is your P data. Okay. Anything here that's different from your panel data? Anyone notice anything, class? What do you notice, class? Any glaring difference? Please, class. Anyone? Take a look at the leftmost portion, class. Okay, thank you. Thank you, Margaret. The index has been changed to reflect the panel data, the company slash dash the year. Okay, right, class? We define the index here. Index is, take a look here at your P data, at our code. Index is equal to firm and year, right? Firm, year. So our data became index is firm and then year. Okay, so the default was to arrange it by company. So company 1, 2015, 2016 until 2019, and then company 2. Because we set the index to be firm and year. Okay, we could have let's replace this. Okay, let's create this one, 1. And then if we change it to year and then firm, what would have happened? Okay, let's run this. I want the view. Their class. So this time it's arranged by year first and then firm. 2015 company 1, 2015 company 2, etc. So depending on how we want it arranged. But usually let's go back. We still have P data. We'll be using P data. Okay. All right. I'm going to share with you some two plots here. Okay. However, there are not so good plots and scatter plots. Let me see how. Okay, these two. Control C. Okay, let me share with you this code. Oops. Sorry. Should be chat, not share. Okay. All right. So copy this code, class, and let's take a look at it. So we can use the coplat function. Okay. So what are we plotting? We'd like to plot the price. Okay, price, plot, price, okay, per year given the firm. And the first plot here is line. Type is equal to L means line. Type is equal to B here means points and lines. So if I run both, let's see. Okay, I have to, something's there. Okay, so it's not so clear, class, but you can see here on the y-axis you have your price, and then on the x-axis you have your year. So this is 2015, 16, 17, 18, 19. Okay, 15, 16, 17, 18, 19. And you have here some dots here. The dots here represent your companies, the firms. There are 16 all in all. However, it's not that apparent. It's not very much seen because because the values are almost the same. Okay, except for some firms here where you can see they have higher values, much higher values than the other years. But the others mostly practically the same, very small difference. So this is the plot of your year. Okay, where's this one? Let me close this. Okay, or you can do it. Uh, let's see, class. I'll copy this, Control C, and then let's create another. You can change the direction, but it will not be also that that good because we have so many companies. 16, Control B, and then I'll change this. I'll just run this firm by year. Okay, I'll run this second point. Okay, you may copy from your own code there. Control Enter. Okay, what happened here? Now it's plotted by company, by firm. Okay, so this is firm 1, 2, 3, 4, 5. Okay, 5, and then 6, 7, etc. So you have now plots by firm, and then this is 2015, 2016, 2017, 2018, 2019. Okay, you can see that there are some firms that have higher, much higher values of price as compared to the others. Okay, so let's take a look at other plots here. Let me close this. Okay, that's the co-plot. Okay, you're plotting both depending on the order, the unit and the period. In this case, firm and year. So you can see the progression. Okay, you can also create scatter plots. I think I shared this with you. If I run this scatter plot, okay, so below, there you go. So you have different shapes for different firms, and both shape and color code. This green one is 13. Okay, so you'll have to look what's company 13. Okay, and you can see the price of company 13 was really going down. The others are practically the same, practically the same prices. Okay. All right, then we can take a look also at this time, this, I mentioned this a while ago, this one. Okay, so I'll share up to the descriptive statistics chat. Okay, so copy those codes, class, and then let's discuss it one at a time. This one, we are plotting the means price, okay, plotted against the firm. Main is heterogeneity across companies. Data is equal to panel data. If I run this, okay, this is quite similar to the other one. You can see here that these are the these are the firms, 19 firms. Okay. This is firm 1, firm 2, firm 3. Okay, you can see that firm 5 and firm 6, they have the highest. I think here they computed for the average. Okay, average across 5 years. So you can see here that the highest average is firm 6 and then firm 11. Okay, almost tied with firm number 5. And you can also plot means, yeah, it's plotting the average. If we interchange this price based on year. Okay, price based on year. Okay, so this is year 2015, 2016, 17, 18, 19, and it got the average price for the whole 2015 of the 16 companies. So these are averages. So this is called plot means. Okay, let me pause for a while and seek your questions if you have any. Is it clear? Kindly chat, class, if so far clear tayo. It was more about the plotting so far. Okay, good. Thank you. All right. So we can do also, when you do analysis, let's say whatever kind of regression, it's important to know the behavior of your parameters. So this one will give us okay, chat. Okay, we're using here the function fb6 and then the package fb6 class. And then this is the function basic stats, the data, and then the the variable, okay, $CR. So if I go to price, control enter, we can see here, this is just like the summary function. Okay, you have number of observations, 80, any missing values, minimum value, maximum value, first quartile, third quartile. Okay, there are others here. You have the lower confidence level for the mean, upper confidence level, variance, standard deviation, skewness, and kurtosis. So the most important descriptive statistic measures are provided here. So it's also important to do this when you're doing panel data so that you can see, of course, there's described by so many other functions. I just introduced to you this basic stats. Okay. All right. So you can run that, of course, class. You can run this, and then it will give you the basic statistics of this financial metrics. Okay. Are we good so far, class? Let me pause for a while. Any questions so far? Questions?
Sir. Sir.
Yes. Plot means, pag ganyan class, kunyari you're interested to get the package, ang gawin nyo dito, no? Question mark, plot means. Here. Okay, so saan to? Control Enter. So it will help us in the viewer section. Dito, no? Lalabas siya. Yan. Plot means, this is from Gplots. Here class, the one that we loaded a while ago. This one here. Gplots. Okay, let me write that here. Gplots. Okay. Thank you, Ian, for your question. Okay. So let's now go, class, to the modeling of our panel data. There are three main methods, class, to model your panel data. Number one is the pooled OLS. Okay, we'll study the distinctions between them, and I'd like you to do some research also. The difference between the three methods. So let me write those three methods. Three, okay, most popular or most common. In panel data. The number one, you have your pooled OLS, pooled ordinary least squares. Number two is your fixed effects. Number three is your random effects model. Okay, so these three methods. Okay, there are others, but these are the most important ones. So let's start with pooled OLS. Pooled OLS, class, is let's say very known to you. Very, you know this, class. Let me, okay, let me just comment that out. So I'll share this with you. Control C, and then Control V. All right. So take a look at our model class. We're creating this object called pooled method. And notice now that it's no longer LM, but it's PLM. It's panel linear model, and PLM. Okay. If you want to know from which package this comes from, PLM. Here, class, PLM. And it will sa help function pala, not viewer. Help function, control enter, sorry. Okay. PLM. So where is it coming from, class? From PLM mismo. This one. Panel linear model. Here. Okay. So PLM package is a function called PLM. Okay. So going back here. Okay. So PLM, our dependent variable is price. And then you have here all your predictors. Okay. These are all our predictors. And then data is equal to, we have to use the P data already, the converted data, the index data. And then pooling is equal to, model is equal to pooling. So that's why this is called pooled OLS. And then let's summarize this. So this is the result. As you can see, you have one significant predictor, earnings per share. Okay, the others are not significant. Okay. Now, pooling method class, pooled OLS, is just the same as your ordinary least squares. So let's have this quick exercise. So maybe you can copy this and change it into OLS and then use the regular linear model method. So replace PLM with LM and then change this to data is equal to P data only. Don't have to put model pooling. Okay, so you know how to do regression, right? The ordinary LM. So you regress price on all the variables and identify the data to be P data, or actually you can use panel data. You don't use P data but use panel data. Okay. So this one, can you see panel data because okay, can you try that class please? OLS method. So I created this object called OLS method and you're doing LM, linear model, price regressed on your current ratio, debt equity ratio, EPS, etc. Let's see what happens. And how does that compare with your pooled method? Any comment, please? Please chat in the chat box, class. How does the pooled OLS and the OLS method fare? How do they compare? Still waiting for your comments, please. Difference, class, between your pooled method and your OLS method. This one we know, class. We have been studying this. Okay. How does that compare with your pooling method? I'm waiting for your response, please. I don't see any response, please, class.
Wait lang, sir. Sandali po. Typing in OLS.
Copy nyo rin nasa taas, yung sa pooled. Modify nyo lang yung ibang ano. You don't have to write everything. Kasi pareho lang naman yung may tatanggalin lang naman kayo, di ba? What's different between the two, class? Come on, class. We're running out of time. I have to run also the others. Okay, even if you're not sure with your answer, Bea, kindly share your answer, please. Okay lang yun. Thank you, Jay. Bea, also share your answer. Mas mataas slightly yung adjusted R squared sa LM compared to PLM. And there is a balance panel in PLM method. Okay. Thank you, Jay. How about the others? Bea, would you like to share your answer? Mas mataas. Yung iba walang comment, please. Dalawa lang nag-comment. Hello, class. Come on, we're running out of time. Did you run it? Sige, ganito muna yung tanong ko, class, kasi parang ang hirap mag-draw out ng ano sa inyo, ng information eh.
Yes po, sir. Mas slightly higher yung F statistic sa ano, sa OLS. 3.475 compared to 3.7482. And
That's
mas
practically
hindi ka.
nothing. Wala. 3.75, 3.74. The answer, class, is they're the same, class. Yung pulled method and the OLS method, it's the same. Okay? Kung may ano man yan, rounding off error na lang yun na but they're practically the same. Isa lang yung significant predictor, EPS lang, 0.044. Okay? 3 significant at 0.001. Ganon din dito, class, sa ano, pareho lang, exactly the same, class. Therefore, what I'm saying is that the pooling method is just the same as the OLS method that we use, class. So sa pooling method, class, what is done is that, okay, disregarded tong firm na to at saka year na to. Okay, we treat this as just a cross-sectional data ito. It's just like having 80 observations, 80 companies, okay? And then 1 year lang yan. Okay? And that's a cross-sectional data, di ba? Many units, one period of time. So when you do pooling method, class, it's the same as doing just our regular LM method. Okay? So that's what I wanted to point out. Kasi parehong-pareho naman, no? Di ba? Exactly the same. Okay? Yung sinasabi niyong F-stat 3.045 dito, 3.045 din eh. Di ba? Pareho lang siya. And then the adjusted R squared is 18.89 here. It's 18.9. Na round off lang. So our model, class, our model is only, of course, dapat mag-stepwise pa nito, no? Kasi hindi naman kagad na ito na lang final model EPS. You'll have to do stepwise because some of these variables might become significant when you do stepwise. So you can use OLSRR, you can use step AIC. Okay? So but in terms of this output, they're the same. Okay, pareho lang, class, yung OLS na pooling at saka OLS method natin. Okay? So I hope that's clear. Now, second, let's have another model. The second model is what we call fixed effects. Okay, I'm going to share this. Control C. And I want you to, class, I want you to learn on your own, research nyo please, kung ano yung fixed effects. What's the difference between your pooled and your fixed effects? So let's run this. Let's see if there will be an improvement or a difference between our our pooling and our fixed effects model. Let's run this. We're creating this object fixed method, same regression, same data, but the model is equal to within, class. Okay, kanina model is equal to pooling. Ito, dun sa P-data natin. Pooling. Tapos pag fixed effect, model is equal to within. Okay, so if I run this, what happens? All right, so there's a change in solution, class. You can now see that in the fixed effects, wala tayong intercept. Okay? Wala tayong intercept. Tapos, significant si current ratio, debt to equity ratio, and EPS, and si interest rate at at 10%. Significant siya. And take note, your adjusted R squared is 51.4%. So a lot higher than your pooling or your pooled. Okay? So magkaiba, class, no? Magkaiba yung method ng pooling at saka dun sa fixed effects. Now, it is your role now to try to study, i-research no, class, ano yung difference ng pooling? Yung pooled, alam natin yan, no? Pooling is just the ordinary least squares. Yung fixed effect, what's happening here? Okay? what's the consideration for fixed effects? And lastly, class, in the interest of time, isa pang method, random effects. Control C. I'm going to share this with you. And then Control V. Okay. Notice how it's crafted. Pareho lang siya. So we're creating this object random method. PLM din. Same din yung regressions natin. Data is equal to P data, but this time model is equal to random. A while ago, it was model is equal to pooling, model is equal to within, and model is equal to random. Okay? All right, let's run this and let's see what happens to your random method. Okay. Sa random method class, meron ditong, okay, this is another thing for you to study or to research, please. Alamin nyo ano tong effects na to, ano yung idiosyncratic at saka individual, ano yung theta. Okay? How do you interpret this? How do you interpret in a random effects model? Meron tayong idiosyncratic variance, standard deviation, at saka yung individual. Notice yung share dito, 1, no? Ibig sabihin, walang share si individual. Okay, theta is equal to 0. And then, take a look at your model. It seems that it's almost similar to, parang pareho lang siya ni pooling, di ba? Diba? Kasi ito, 3 stars, then 0.044, and isa lang yung significant predictor. And then also, the adjusted R squared is pareho lang, 18.9%. Okay? So it's not different from your pooling. So in this case, si random at saka si pooling pareho lang. Now, we will have to test. From the looks of it, class, based on adjusted R squared, parang mas maganda si fixed effects, no? Kasi adjusted R squared niya, 51%. Tapos tatlo yung significant predictors. Okay? So, let's now, class, I'll share this test with you. Sabay-sabay ko na. Control C, chat, Control V. So please copy these tests. Kasi we're going to test, class, statistically, sino ba mas maganda? So we'll first use the Chow's test or the F test. Okay. So the null hypothesis here is that, class, it's almost time. I hope you can give me just 1 or 2 minutes. No? The null hypothesis is that the pooled OLS is better than the fixed effects. So we're comparing here fixed at saka pooled. Okay. So if we run this, class, run. Okay. Then what do you have, class? Using the F test, class, to test whether which is better, the fixed or the pooled method. You have your p-value here at less than 0.05. Therefore, we reject the null hypothesis that the pooled OLS is better. So if you're comparing fixed effects and pooled OLS, mas maganda si fixed effect. Okay? Next, let's go to the Lagrange multiplier test. Here we're comparing si pooled naman at saka si random. So usually, kino-compare mo natin si pooled with fixed, pooled with random. So this is the function PLM test, pooled, and then just we have to, pwedeng ilagay na natin dito type is equal to si Bruce Pagan test. So Bruce Pagan yung gagamitin na method. Okay? Understood na yun na PLM test, you're comparing your pooled at saka yung random. So define natin yung pooled. Okay, and then type is equal to Bruce Pagan test. Run natin to. So again, your p-value is less than 0.05. So we reject the null hypothesis that the pooled OLS is better than the random effects. May mga random effects, class. Okay? There are random effects. Okay, so between pooled and random, mas maganda si random. Between pooled and fixed, mas maganda si fixed. Now, the last step is your Houseman test. Okay, we're now comparing the random effects at fixed effects. Okay, so the test is P, panel, Houseman test, fixed method, and random method. Okay, sorry, ito na ulit lang to, no? So tanggalin nyo lang to. Na doble to. Okay, all right, so let's run this. And, okay, the p-value is very, very small. Okay, which means that we reject the null hypothesis that the random effects is better than the fixed effects. There are fixed effects. Okay? So your goal class is to learn ano ba yung difference? Yung pooled kasi alam nyo na yan eh. Ano yung difference ng random at saka fixed? Okay? And also, ano sa random may lumabas dito na effects, di ba? What's this? What's the idiosyncratic effects at saka yung individual effects at saka yung theta? All right? So with that class, next week is independent learning week. I'll be posting some videos class this week, no? Kasi baka magalit kayo sa akin na next week ako magpo-post. Please find some time to watch the remaining part of the video about panel data regression. Kasi ang goal natin, sana if you watch the videos, tapos independent learning week kayo, spend some time reviewing class kasi next week, next week, di ba may ano tayo? May exam tayo, face-to-face exams. And then after fixed effects class, our next lesson will be, after panel data, our next lesson will be structural equation modeling. So we're going deeper into more advanced models of regression. Okay? So I encourage you class to learn. Please read on ano ba yung difference ni fixed effect at saka si random effects. Bakit may ganyang method? No? And why is it true for a panel data regression model? Which is not for wala tayong fixed at saka random sa isang cross-sectional data. Kasi wala naman tayong time na tinitingnan dun, di ba? Isang time lang yan. Okay? So let me stop recording.